Okay, this is the Unit 4 review guide. We're on question 16. We'll try to get through 16 through 19 in this video. Topics 12A, B, and C. So it says, use your graphing calculator to find one real zero, then use synthetic division to completely factor and find all the zeros. All right, so on this first one, if we put this in, x to the fourth plus 7, x to the third minus x squared minus 67x minus 60. Oops. Ugh. All right, let's try that again. X to the fourth, and I will make sure I bring it down this time, plus 7x to the third minus x squared minus 67x minus 60. All right, let's graph it. All right, it crosses 1, 2, 3, 4 times. That means I need to look for 4 zeros. My answer in the end, I should have 4 different zeros. Right now I just need one of them. So let's go to table and see if we can find a spot where there's actually quite a few. Looks like I can get most all of them from here, but let's just pick one. So let's say I pick 3. That's a 0 because my y value is 0. It's an x-intercept. So we're going to put that outside and write all of our coefficients, making sure that we have all of them. 4, 3, 2, 1, 0. Yes, we have them all. So 1, 7, -1, -67, and -60. So again, these are all my coefficients. The first coefficient comes down, and then I start multiplying. So 1 times 3 is 3. Add 7 plus 3 is 10. 10 times 3 is 30. -1 and 30 is 29. 29 times 3 is 87. -67 and 87 is 20. 20 times 3 is 60. 60 and -60 is 0, which is good because it should be 0 because this is a factor. All right, so now I need to keep going. Remember that this is x to the fourth. So this means x to the third plus 10x squared plus 29x plus 20. So we need to find another 0. So we can put this in our calculator. X to the third plus 10x squared, whoops, plus 29x plus 20. Oh, there's a 0 right there, -1, 0. So we're going to do this, -1. All my coefficients, 3, 2, 1, 0, I've got them all. So 1, 10, 29, and 20. First coefficient comes down. 1 times -1 is -1. 10 and -1 is 9. 9 times -1 is -9. 29 and 9 is 20. 20 times -1 is -20. That's 0 because it was a factor. All right, this now leaves me with, remember I was on x to the third, so I got to go down 1 to x squared plus 9x plus 20, right? Because these are my coefficients, and the last one's my constant. This one I can factor pretty easily. It is a quadratic with an a value of 1, so I'm looking for two numbers that multiply to be 20 and add up to be 9. Those two numbers are 4 and 5, so x plus 4, x plus 5. And so that means when I set those equal to 0, I have x equals -5. So factored form of this, there's one factor, so add an x, switch the sign. There's another factor, add an x, switch the sign. And then these two factors are already in factor form, x plus 4, x plus 5. Zeros means set them equal to 0 and solve. When I set this one equal to 0, I get 3. When I set that one equal to 0, I get -1. That one gives me -4. That one gives me -5. So that means for this polynomial, it crosses the x-axis at these 4 spots. And this is my factored form. So let's try one more. So we've got this one. It says, again, we're going to use our calculator to find one real 0. So let's put in x cubed minus x squared plus 49x minus 49 I'm going to look just to check to see how many times it crosses. It only crosses one time, but that doesn't mean that there's only one solution. There could be imaginary solutions to this. We'll have to wait and see. So let's see what that one solution is. Looks like it's at 1, 0. We put the 1 out there, we check 3, 2, 1, 0. Yep, I have all of them. So my coefficients go here. The first coefficient comes down and I start multiplying. 1 times 1 is 1. Negative 1 and 1 is 0. 0 times 1 is 1. Oh, sorry, 0 times 1 is 0. 49 and 0 is 49. 49 times 1 is 49. Negative 49 and 49 is 0 because it was a factor. It was a solution. So now what I'm left with, I started with x to the third, so I know that this is the coefficient of 1 less than x to the third, or x squared. I don't have an x term, and then I have this. So it's not a difference of squares. It's not a difference, it's addition, but it is 2 perfect squares. I'm going to have to do the quadratic formula to solve this, because I can see I can't factor it. So my a value is 1, my b value is 0, and my c value is 49. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this simplifies. This is just 0. So I have plus or minus, and this is just 0. When I simplify this inside part, I get the square root of negative 196, and then the bottom part simplifies to 2. So you should, before you do a factor tree, I would always check to see if things are perfect squares, and it turns out that 196 is a perfect square. The square root of it is 14, but it's not 196, it's negative 196. So that means that negative comes out as an I. So I have 14I over 2. So again, the reason why it's 14I is because the square root of 196 is 14, and that negative right there, that's why I have the I out there. This simplifies to plus or minus 7I. So here's my zeros are, I have 1, 0, I have positive 7I, 0, and negative 7I, 0. In terms of a factored form of this, I have x minus 1, x, because I'm switching the sign. If I switch the sign of negative 7i, I will get positive 7i, and if I switch the sign of negative 7i, I get, or sorry, if I switch the sign of positive, I get negative. So that's my factored form. I can multiply these out as well. So if I multiply those, what I get is, kind of running out of space here, x 7i, x negative 7i. X times x, and then I have negative 7ix, positive 7ix, and this is negative 49i squared, except we know that this I squared is negative 1. So this is actually negative 49 times negative 1, or positive 49. These two right here cancel out. 7ix minus 7ix, they're gone, and I'm left with x squared plus 49. So I also could say this is x minus 1, x squared plus 49. All right, number 18, write a polynomial function of least degree that has coefficients negative 3, 4, and I as zeros, and a leading coefficient of 1. Hint, if x equals I is a 0, what also has to be a 0? All right, to start with, to go from zeros to factors, or roots to factors, or x-intercepts to factors, you need to add an x and switch the sign. So here, if I have negative 3, I add an x and I switch the sign. 4, add an x and switch the sign. I also have I. So the hint down here, if I is a 0, what also has to be a 0? I first. So add an x, switch the sign. Remember we did this before. If I have I, the other solution has to be negative I. And if I have negative I, if I add an x and switch the sign, I get plus I. So now I want to multiply these out, kind of like what I did on problem 17. So I've got x and negative I, and x and positive I. And when I multiply them out, these two cancel, and negative I squared is the same thing as negative 1 times negative 1, or 1. So I end up with x squared plus 1. So I would have f of x would equal this part, x plus 3, x minus 4, and then x squared plus 1. That is my factored form. All right, last one. Circle all the zeros of the function, then write f of x in factored form. All right. Nowhere does it say I have to do synthetic division, or nowhere does it say I need to try factoring. I'm going to put this in my calculator. X to the third plus 3x squared minus 18x minus 40. First of all, let's see how many there's going to be. Looks like there's going to be 1, 2, 3. So I'm looking for 3 answers. If we get them from the table, that's our easiest way. I'm looking for where y is 0. So one of them is negative 2. Let's look for some more. One of them is 4. Let's see if I have any more from the table. Oh, there's my last one, negative 5. Remember, if I can't get them from the table, I can do second calc number 2 and get them that way as well. All right, so those are my zeros. To put it in factored form, we do this. You really have to know this. We add an x and we switch the sign. So add an x to 4 and switch the sign. Add an x for this negative 2 and switch the sign. Add an x and switch the sign. So there's my function in factored form. We found these from our calculator, and then we added an x and flipped the sign.